Welcome back to Elements of Chemistry. Today we're going to talk about the states of matter, primarily the four main states of matter: solid, liquid, gas, and plasma. These states of matter are distinguished by how they behave according to the kinetic molecular theory. And we're going to keep coming back to that topic. Kinetic, motion, molecular, the models. So we're going to be talking about how the motion of the particles affects the state. So each state can be described based on its density and the kinetic energy of the particles. When we look at a solid, these are the most tightly packed particles. The particles have little freedom of motion. Solids are considered to be non-compressible because if you look at our description here of a solid, there's no real space between the particles. They're jiggling in space. Yes, they are moving, but they're not moving very much. They're kind of locked in place. It's like students sitting in their desks, not moving. This is the lowest kinetic energy state, and it's the highest generally of the density states because the particles are most tightly packed. If you remember, or you will get to in a future video, depending on what order you're watching these, density is a measure of how tightly packed things are. Solids can be classified as either crystalline or amorphous. Crystalline solids are in a neat, orderly arrangement, whereas amorphous, the particles are a little more loosely held. This would be like a quartz, which is a crystal, or diamond, which is a crystal, versus flour or baking soda. It's just amorphous. It's there. It's a pile of the powder. The powder is a solid. Okay, a liquid is more loosely packed. The particles have a greater degree of freedom of motion. They're considered non-compressible because there's not much space between the particles. In a liquid, the particles just slip and slide past each other. We show motion with an arrow. So we can show that things are moving, they're sliding past each other. The longer the arrow, the greater the degree of freedom of motion. So in a solid, yes, they're jiggling in space. They might have just a little teeny tiny arrow of motion. Liquids have a definite volume, but they have no definite shape. A solid's got a definite shape and volume. A liquid's going to take on the shape of its container. So you can kind of pour it into anything and it's going to take on that shape. And it's considered the intermediate of the density states. So if we look here at the states of matter, solid we can see is tightly packed. Liquid, there's a little more freedom of motion, and we would show a liquid on a particle diagram as having little short arrows showing the motion. And a gas has the most kinetic energy. So it's going to have a longer arrow, and a gas is going to move in straight line motion. And the speed, once again, of the particle is based on the length of the arrow. Now, a gas is considered compressible because if you look at a gas, there's a lot of space between those particles. And technical term, we can smush them together. They have the lowest density. And then the next state's the one that's a little harder to understand, plasma. This is a high temperature state where the particles have ionized or they've lost their electrons. So you have collections of positive particles and negative particles in the plasma. This is going to have the greatest kinetic energy because it's the highest temperature. Kinetic energy is motion. Temperature measures that motion of the kinetic energy. And this is a state of matter that occurs in hydrogen burning stars. You'll see it in welding torches. It is not that uncommon for us to encounter plasmas. Okay, so we remember our states of matter are pretty much classified based on the degree of freedom of the motion and their temperature. And this is a great picture I took from the Alami site, so give them credit for it. And you can see that solid, the most tightly packed, looser liquid, gas far apart, plasma even farther apart, and the plasma is showing your positive and negative particles. If we move beyond these four basic states of matter, there are two more that are rarely given a lot of discussion in on-level chemistry and physics classes, but we need to mention them here at least. The Bose-Einstein condensate. This is a unique state of matter when gas is cooled close to absolute zero. And this will cause photons in certain atoms like helium-4, sodium, and rubidium to occupy the lowest possible quantum state. This causes the particles to behave as a single wave function. As the temperature increases, the kinetic energies, as the temperature decreases, the kinetic energy drops. and the de Broglie wavelength, the wave-like properties, increase. De Broglie said that all particles have a wave characteristic. This is that particle wave duality you may have heard of, especially when we talk about light and photons of light. Well, at its low temperatures, the wavelengths begin to overlap, causing the atoms to collapse into this lowest quantum energy state, forming a condensate. These condensates will act as a superfluid. A superfluid will flow without any viscosity or resistance to flow, and this occurs at very, very low temperatures. For helium-4, it's at 2.17 Kelvin. For sodium, it's below 200 nanokelvin, and rubidium below 150 nanokelvin. So we're talking really, really cold. We're getting really, really close to absolute zero here for these superfluids to occur. But superfluids could have some really interesting, unique properties. Another one that we're going to see, and you're going to hear mostly about if you do astronomy, is neutron degenerate matter. This is an extremely dense form of matter that's found in neutron stars. In a neutron star, the density is on the magnitude of 3 times 10 to the 14th grams per milliliter. It's just absurdly high gravitational pull. It's really cool if you want to do some investigation to go look up neutron degenerate matter, but it's not something you're going to typically hear about in a traditional high school course. In a traditional high school course, they're going to stick to the solid, liquid, gas, plasma. Know that a solid's most tightly packed. It has a definite shape and definite volume. A liquid has a definite volume, but no definite shape. The particles have more kinetic energy than a solid. In a gas, we have higher kinetic energy. The particles move in straight line motion. A gas is compressible because there's a large space between the particles. And then a plasma is an ionized gas at very high temperatures. I hope this helped you understand a little bit about the states of matter. As always, stay curious, be safe, and be kind to one another. I hope you have a great tomorrow. Have a wonderful day.